Hello guys, welcome to Ramta Solutions. Today in our lesson exercise 2 of vertical projectile motion, we're looking at a case where a ball is thrown vertically upwards and returns to the thrower's hand 4 seconds later. Alright, so as you can imagine, this is the ball. The motion of the ball is like this. This is it initially and this is it finally. This entire motion lasts for 4 seconds. Right? Question A says, calculate the velocity with which the ball left the thrower's hand. There are two options to doing this. So let me start with option 1, where I'm looking at maximum height. To reach maximum height, if the entire motion is 4 seconds, to reach maximum height, because we spoke of time symmetry, it'll take it 2 seconds, right? And we know at maximum height, velocity is 0. So we will say VF, before that, let's say upwards is positive. Okay, I will take upwards as positive. Remember, even if you take downwards as positive, as long as you are consistent with your signs, you will still get the same answers. Okay, so final velocity equals initial velocity plus a delta t. What is our final velocity? At maximum height, the velocity is 0. Now, what is the initial velocity? We do not know. Upwards is positive, and because gravitational acceleration is a downwards motion, it will be negative 9.8. And the time taken to reach maximum height was 2. Now 0 equals VI minus, this is 19.6, I believe. Now our initial velocity is 19.60 meters per second. It's a positive answer, so this means upwards. Remember, velocity is a vector quantity. Okay, now let's look at option 2. For option 2, we will consider the entire motion. Remember, if this is initial velocity and this is final velocity and this is the same point, initial velocity will be equal to final velocity but in opposite directions. Therefore, we can say final velocity is equal to negative initial velocity. So I'm still gonna say upward as positive. Alright, now the formula we're going to use is still the same formula. So VF equals VI plus A delta T. What is VF? We said VF is negative VI. We don't know what these VI's are. Our acceleration will be negative because we chose upwards to be positive. So since we're considering from start to end, this motion lasts for 4 seconds, so I'm gonna put the 4. Now we have minus V. If I take V to the other side, we will have negative 2 VI, right? Equals, this is negative, I think it's 39.2. Yeah, 9.8 times 4 is 39.2. Okay guys, now if somehow I confused you here, what I had said was this is minus VI. If the VI, this VI goes to the other side, it will be another minus, so this will be minus 2 VI, like terms, right? Okay, now what is VI? VI is 39.2. The half of 39.2, it's 19.6. Yeah, it's 19.60 meters per second, where it's positive, so it's upwards, because negative divided by negative is positive. Alright, so this is how you can calculate it. Okay, alright guys. Number B, we're going to look at, they say we must calculate the height reached by the ball. We know this is maximum height, right? So we have already calculated this guy, and we know at this point velocity is 0. So we are looking for delta y, right? So let's see, we can use the formula vf squared equals vi squared plus 2a delta y. You can also use delta y equals vi delta t plus half a delta t squared. Alright, you can still use this one, you will still get the same answer. However, I will go for the first one. Now, this is a vector calculation, so the direction that I choose to be positive is the upwards direction. Right? So I will say vf squared equals vi squared plus 2a delta y. What is vf? At maximum height, velocity is 0. What is our initial velocity? We found it to be 19,60. Our acceleration will be negative 9,8. We do not know what this guy is. Okay, we do not know what this guy is. So 19,6 squared is, so this is 0 equals 384,16, and this one here would be 19,6 delta y, right? Sorry, delta y, not delta t. Right? Cool. Now we have 19,6 delta y equals 384,16. So this answer divided by 19,6. Okay. So 384,16 divided by 19,6. Our answer is 19,6 meters. As you can see, it is a positive value to tell you that this height is above the thrower's hand. Okay, cool. Therefore, you can conclude the height. Maybe let me conclude it by saying, therefore, the height reached was 19,6 meters above the thrower's hand. It's okay to say the thrower's hand. Okay, I'm just stating this to help you make sense of the question. All right, okay, but even if you leave it here, it's still okay. Now, number C, the velocity with which the ball returned to the thrower's hand. If you remember well, we said initial velocity equals negative final velocity, or we have also said final velocity equals negative initial velocity, which is negative 19,6. Remember, we calculated initial velocity. Therefore, what is our final velocity, or velocity with which the ball returned to the thrower's hand? It is 19,60 meters per second downwards. This question will be 1 mark or 2. So this is it. This is how you calculate it, or rather this is how you get it. You didn't even have to do this. You had to remember the information I gave you where the information I gave you here, that on the same point velocity is the same. is equal in magnitude, but of course it's in opposite direction. Okay. All right, guys, so this is it. Stay tuned for the next video. In the next video we will be looking at this beautiful scenario. So stay tuned. See you next time, and bye bye.